values of the constants v sub h, assumptions noted, the system sum of k from 1 to p in the p unknowns of the integral from a to big P sub k of du sub h equals v sub h. So again, it's this interesting form where it takes a sum, which these integrals of those being the paths, which kind of is a way to write this integration, this maturation of these things. In the p unknowns, p sub k, k less than or equal to p, has a unique solution. So you have, it's basically the Abel's theorem is there's a constant, and Jacobi's theorem is there's a unique solution. Now, this can be argued for some of these algebraic varieties about some of their singularities when there's anything to do with about the path. And so sometimes people talk about the hairy ball theorem. What's the hairy ball theorem? Well, anytime you try and comb it and lay down all its hair flat, at some point in time it would have to have a curly Q. And it's well, what if you just ignore the poles and just comb around it, so that basically it just has a removable bald spot at the north and south pole, and you just call it Coriolis style? Anyways, that's as to whether it's just an example of a contrived type of thing. It's like, well, okay, maybe it doesn't have that when there's a particular singularity that puts an axis through the whole thing, that then you can't otherwise ascribe to attain for that's a removable singularity for these removable discontinuities. Yeah, okay, but maybe not. Periodic properties that the set d sub d of u sub h be as just stated, and let gamma u to the L mu, or gamma sub mu to the L, mu less than or equal to 2p, be an integral homology base for the module of 1 cycles of f. The expression pi of h mu equals the integral of gamma sub mu 1 du h sub h is a period of integral du sub h as to the cycle gamma mu L. Let the matrix, this product, or pi, big pi, equals the matrix of little pi, h sub mu, h and mu less than or equal to 2p, and pi of h plus p mu equals pi tilde h mu, h less than or equal to p. By means of integration on the Riemann surface F, Riemann has obtained the following comprehensive result, formulation of Scorza. And that's the theorem of Riemann that was read, that is positive definite Hermitian matrix. Factors unity. Riemann matrices. This is the name given by Scorza to a matrix like pi satisfying relation, except that M is merely rational skew symmetric. The theory of such matrices has been extensively developed by Scorza. He called M principal matrix of pi. It may very well happen that there is more than one rational skew symmetric matrix M satisfying a relation, but without necessarily the positive definite property. These matrices are called singularity matrices. They form a rational vector space whose dimensions k is a singularity index of the Riemann matrix, Scorza. And then, for example, and this is just in the preliminaries, and he's getting us some results of Poincare. Talks about compact orientable manifold intersections. In my work on algebraic geometry, I freely use the intersection properties described below. They are actually justified and proved topologically invariant a couple of years later in my paper in the 1926 Transactions, and much more fully in this later reference. Let M star be as before, and let gamma p and gamma q be an integral p and q cycles of M star. So I need to see, let M star be a compact orientable N manifold which admits a cellular subdivision with alpha sub k cells, well-known property for varieties. So here, this whole idea of the cellular subdivision kind of reflects the notion of a cellular subdivision. And K cells, and alpha K many, those are usually like nearest neighbors and this and that, topologies, lattice. The characteristic is the expression chi of m star equals sum of -1 to the power of k, ak. So it's even or odd, and it's just the sum of those. Some of those even or odd. Cellular subdivisions. The following two relations were proved by Poincare. Chi m star equals sum of the -1 to the power of k, r sub k, where r sub k equals r sub n minus k, where r sub k is the kth integral Betti number of m star. So it looks like I'll need to study the Betti numbers. Maximum number of linearly independent k cycles with respect to homology equals with respect to bounding. Well, that just seems kind of a usual. It's like, think of the plane as everywhere just varying a little bit, so it's just like little dimples everywhere from both sides. Then anywhere in a region add up to 0. But this is a way to think of that as, like, as we were talking about the Fourier analysis before, when you have these removable discontinuities, and it might be a little bump as long as it doesn't blow up. That Poincare is kind of saying is like, hey, look at this. It's kind of like a continuum is bumpy while it's smooth. And again, I may be misreading that, but I'll refine that later, or eat my words. Intersections, so let m star, Then we can define the intersections, and it is a p plus q minus n cycle. The more important situation arises when p plus q equals n. So then it would be a 0 cycle. The intersection geometric approximation is then a 0 cycle. C to the 0 equals the sum of the s sub j, a sub j. Where the s sub j are integers, the intersection number of y to the p, or gamma to the p, gamma to the n minus p equals the sum of the sj's, is independent of the approximation. One proves readily that the intersection number of gamma p, gamma n minus p equals -1 to the n minus p times p times the intersection number of gamma n minus p, gamma p. So it just sort of shows that there's symmetries about this kind of thing, and this property of the inverses here, that inversing the parameters to this function, or what goes in to make this intersection number is got a formula relating in terms of the other one, just in terms of that it's basically odd about it as to whether the n minus p and p are even or odd. That either both are even or both are odd. And a basic result is ... So anyways, going on, this is just first few pages, but what it starts to develop is a lot of things that have been gathering dust, for quite a long time. And this book was published in by the Chelsea Publishing Company, Bronx, New York, 1971. And as it says in the preface, it says, a discussion of Professor Lefschetz's work, if one were to be offered here, would require a great many pages written by experts in more than one field of mathematics. Indeed, to quote Professor Norman E. Steenrod, a full story of his influence in algebraic topology would require a review of the entire field. Fortunately, there is a survey, some 43 pages in length, by Professors W.V.D. Hodge and Norman E. Steenrod, to which the reader can be referred. This survey and appreciation of the work and influence of S. Lefschetz constitutes part 1 of the book Algebraic Geometry and Topology. ... in differential equations and applied mathematics is a separate thing. So anyways, he gets into section 5, chapter 5 here, is the analysis Situs, and so I imagine this is his native language. He says, les surfaces et les varietés algébriques accusent, au point de vue de l'analysis Situs, des différences profondes avec les courbes. The surfaces and the algebraic varieties imply, from the point of view of the site analysis, differences that are profound with the curves, differences dues surtout à ce qu'elles ne sont pas la variété bilatérale la plus générale de leur dimension. Differences due overall to their that they don't have the bilateral varieties more general in their dimension. Quatre, pour les surfaces, 2D pour les varietés à des dimensions. Effectivement, elles contiennent des varietés topologiquement très particulières. Effectively, they contain the topological varieties very particular. There's sections par d'autres surfaces of varieties algebraiques. There's sections of the autres surfaces or algebraic varieties. Il est donc assez naturel d'en profiter pour l'étude de la variété elle-même et de plus de rechercher les propriétés spéciales qui en résultent. It is often enough natural then, or it's more so then, to profit by the study of the variety itself, and more to study the properties that are special, which result in it. Après un chapitre préliminaire, c'est là la tâche que nous avons poursuivie dans le second, le troisième, et dans le début du cinquième. After a chapter that's preliminary, there that the tack that we have followed in the second, third, and the beginning of the fifth. Dans les autres, on trouvera diverses applications, notamment à la distribution des courbes, des surfaces ou des hypersurfaces des variétés algébriques. C'est en fait dans cette direction que l'analyse Situs montre son maximum d'utilité. There you can find, one will find diverse applications, notably the distribution of curves and surfaces and hypersurfaces of algebraic varieties. That is in effect in this direction that the analysis Situs, it's Latin, builds itself to its maximum utility. Parmi les divers écrits qui m'ont influencé pendant ce travail sont assignés tout particulièrement les mémoires de Poincare sur l'analyse Situs et sur la distribution des courbes d'une surface algébrique. Les travaux d'Henri Picard, tels qu'ils sont exposés dans le traité qu'il a écrit en collaboration avec M. Simard, enfin, sont des superbes géomètres de l'école italienne. Par un bon part, d'ailleurs, les résultats exposés ici sont inédits quant à la forme ou au fond. Tel est notamment le cas pour ceux relatifs aux intersections de cycles qui paraissent ici pour la première fois. Cette monographie est basée en partie sur une série de conférences faites à Rome printemps de 1921 sous les auspices de l'Institute of International Education ainsi que sur les recherches poursuivies un peu auparavant sous de l'American Association for the Advancement of Science. Au nombre amis qui des deux côtes de l'Atlantique m'ont prodigué their cordial encouragement, Merci d'abord, M. Borel, pour m'avoir accordé l'honneur de paraître dans sa collection. So in this table de Mariès, this is about this algebraic geometry, or the analysis Situs, the geometry algebraique. And so, as I look to it, I'll be curious what all I would get from the same formulas as written in French and English, because any formulas by their symbolic variables should be the same. There's no reason to translate usually letters and symbolic notations among languages. It's its own specialized language. And similarly, any names would be the same for people, and usually then the term will have a direct translation, like courbe is curve, or onde is wave, or this or that. Numbers have their names. That looking to read into this, because really, I want to read Poincare, and for that matter, it would probably be best if I just found a translation, because there's plenty of the technical intent and also in the language's intent these come across. But there's otherwise that French and English are close enough, and they share many of the same objects and verbs, and they basically make an account of each other that is a closed form, that where one may have that the style will vary in terms of the reflexive or the irreflexive or the perfect or imperfect, and these kinds of things between English in its perfect tenses and French in its imperfect tenses, or the massive proliferation of copulas in English, or this notion that there are otherwise what would be more or less expressible. This is in either language, it's about the same what can be expressed. And so I'll look to read how to start to understand the derivations of one language and the other. La considération des nombres algébriques de point d'intersection remonte chroniqueur et de Poincare. So, for example, I've studied French in school for many years, and of course English is my first and native language, and I'm very fluent in it. La considération des nombres algébriques is the consideration of algebraic numbers. De points d'intersection remonte à chroniqueur et de Poincare. Well, we just read about these points of intersection, and here's the same formula. Relevant en particulier les relations suivantes. M sub h, m sub n minus h equals -1 to the h, -1, times the quantity m sub n minus h, m sub h, impair, and then this and that's relevant just as we were talking about these intersection numbers and their relation about each other, and this asymmetric bit when they're reversed, that in the order in terms of when they're like so, that this is just an example of either a similar model, the names are different, but it's about these points of intersection and these numbers and like so, that it would bear further reading to establish about the multiplicity des types restreints du nombre de m sub h, m sub k, se coupant suivant en m sub I de même type, avec L equals h plus k minus n, soit A1 en point quelconque de m sub L et dont et indicatrice A1 ... Nous dirons que MH et MK se coupent suivant plus M1 ou minus M1, suivant que Pn equals A1, A2, ... An plus 1. Et ou bien n'est pas une indicatrice de Wn. Cette intersection orientée sera désignée par MK, MK, MH, MK. Si MH et MK se coupent suivant plusieurs variétés M sub T sub I, chacun orienté à l'hypertome, on écrira M sub H, M sub K equals sigma plus M sub L. Les signes étant déterminés comme avant, on vérifie de suite que M sub K, M sub H equals -1 to the n minus H, with quantité n minus H, quantité n minus K, M sub H, M sub K. Pour L equals Z, donc k equals n minus h, on considère le point m sub L constituant le propre indicatrice p sub 0. À part de cela, rien ne sert à changer. Supposons en particulier qu'il y ait de q sur L de ces points affectés du signe plus q double prime affecté du signe minus. Nous nommerons la différence q prime minus q double prime nombre algébrique de points d'intersection de m sub h avec m sub k par opposition au nombre ordinaire, au nombre arithmétique q prime plus q prime prime. On découvre que pour ces relations plus et minus, pour l'un pour l'autre, il maintient et définir ces nombres algébriques, alors que leur point d'intersection se montre cette relation et ces relations suivantes. Les nombres q prime minus q prime sont désignés par la notation on croit c'est apparaître le même comme les intersection numbers qu'on a lu récemment en la section anglais. Ainsi, si ils avaient la même forme, ils avaient la même fonction, et vice versa. Dorénavant, sauf avis contraire, c'est toujours du premier qu'il s'agira. Ce nombre est destiné à jouer un rôle de plus important dans la suite. Relevons en particulier les relations suivantes, les intersection numbers. La consideration de numbers algebraiques de points d'intersection remonte à Kronecker et to Poincare. Now, when we talk about Kronecker, again, it's one of these things like I've heard a few things about Kronecker, and I don't have much for him, although I know he's a big fan of integers and number theory somehow. Whereas Poincare is kind of known as Poincare is about the best mathematician of his day in terms of the great broad grasp of his intuition and his instinct besides his knowledge of the field. And that he developed a lot of the setting and the milieu for that he would write the reasonable milieu for anything that came up. And Poincare was a great geometer and knew his physics. And then I guess this Kronecker has a lot more to say than about these algebraic numbers than his usual touchstones is what it is. Au fond, nous venons de définir une relation entre les quatre varietés MH, MK, MT, MN, or ML, MN, en vertu de laquelle l'orientation de l'une est déterminée par celle des trois autres. That on virtue that each of their orientations are given the one by those of the others. Un exemple bien connu d'une telle situation est celui de la détermination d'un sous sur la normale à une surface dans l'espace ordinaire quand la surface et l'espace ont été orientés de manière définie. Talking about the normal to a surface in 3D, it seems like. Remarque. Dans toute la discussion, on suppose implicitement que quand A se déplace sur l'intersection MI, Pisman nécessite jamais d'être une indicatrice de WN. Ceci pourrait fort bien se produire un certain point exceptionnel de M, L, mais puisque cela n'aurait lieu dans aucune de nos applications, il est inutile de nous en préoccuper. And so this provides that there's many nuances of the language, particularly with regards to negations, and definitely with regards to the common contents of, and here would be the preliminaries of more usual mathematical terms than in geometry that I feel pretty confident that I could define about a model of geometrical objects that maintain these forms that I've given these underdefined terms, the intersection of indicatrix, the same word. Exceptional points is about that may puisque c'est la normalia, that something else may not be given without otherwise in its applications. That's kind of like long and short form of qualification in a sense. Il est inutile de nous en préoccuper. It's pointless to care. But it has some interest because they're the special points in a sense, or anything to do with this side. Then he refers to Hadamard as the source of this quote about Kronecker and Poincare. So anyways, these are the kinds of things that I've been enjoying about this Lefschetz book so far. And what I'm looking to get into is a lot more of the appreciation of what goes in the algebraic geometry. So kind of like for this whole differential geometry bit and the differential analysis, and reading the fin de siècle, or the geometer's approach, the old school approach for the plane curves and their integral equations, so that when we talk about our differential equations and their solutions, we know that they're the same things, looking at each other. And that goes into a lot of the context that otherwise would have been lost if you just kind of cement over the generations, say, hey, these are the new things we've learned, and now we're up above it. And it's like, well, this is not going to help when the people will lack the instinct and the intuition, which is provided from the fact it's like, well, you have this instinct and intuition, shouldn't everybody else? It's like, well, yeah, but they don't. And so this is what we have. And it's like, well, this is something else. This is similar for the algebraic geometry, because we get in a lot of these different kinds of things, and it's kind of what's risen up to be like category in theory and stuff like that, which is great, and it's possible to establish from many different kinds of terms. And once you get up to a high enough level of those, you can kind of close off particular sections and just have a little diagram that you can run cases around the diagram and keep it on one piece of paper and in one diagram in one box. But here it gets into that there's all this other stuff that can go into developing the structures that model it, that is more important at some point, the structuralism and the constructivist approach. Which is why there's here a thorough deconstructivist approach to make another reconstructivist approach, a constructivist approach. Then a sort of higher synthesized approach, which on the one hand does reflect a gathered instinct and intuition about it, and high level theorems that help guide the study of the relations of things. But on the other hand, is just a bubble waiting to be broken, and then without instinct and intuition otherwise underneath it is an ice cream cone on the ground, and with that melts automatically. It's bad. So these are the kinds of things that the algebraic curves and their abelian sums, that for a formula of Poincare, given us, we have, as far as we're able to tell, p integrals that are distinct of the first order, de première espèce, telka, such that u consider a plus a, that u is large, soit u sub h equals the integral of p sub h xyz over f prime x dx, h equals 1, 2, dot p, p sub h, Searle maintenance supposed to order at m minus 3 plus qk. So he's established that p sub k will be maintained. I need to learn my participles. Supposed of an order that's n minus 3 plus q sub h. And this is as after Picard et Simart, S-I-M-A-R-T. Soit dit un curve algebraique quelconque, coupant h, that D is an algebraic curve, thus that cutting H sub gamma of points M1, M2, M3 are intersecting. D'ailleurs, ces points n'ont pas besoin de comprendre la totalité de groupe DH gamma. Out of this, d'ailleurs, I need to learn this word. Ces points n'ont pas besoin. These points won't need to comprehend, to cover the totality de group DH gamma that we will designate dorénavant, as we will designate as having given the ensemble of the set des points, the intersection des deux courbes. The collection of these points is the intersection of the two curves. On pourrait en fait se limiter à l'ensemble des points variables y compris seulement quelqu'un des points fixes. So he says that there are only these fixed points, des points fixes. L'essentiel pour la suite, c'est de voir sur H sub gamma un groupe de points déterminés rationnellement dans leur ensemble en fonction de Y. Ces points fixes, remarquons là de suite, ne peuvent être que les points A sub I pris chacun un certain nombre de fois. That these fixed points cannot be these points A sub I pris chacun, except for each, a certain number of fois times. Ainsi, pour D equals H, on sera amené à considérer comment groupe particular de points M sub K un quelconque des A sub I. So in this manner, I start to feel like Lefschetz is providing me some instinct and understanding of Poincare's formula about the fixed points, and then that the fixed points is something that has been talked about in the differential analysis, and this is part of the differential analysis, is, although it's kind of part of the methods analysis, but really it's part of the differential analysis, what it's going to be, because it's all getting to be one field here, is that the fixed points and the singular points about 0, 1, and infinity are to basically make for a space where that's kind of so, and to model into that space. Everything from this 3 dimensions of space-time, of space, to the regular singular points of the hypergeometric, an infinite power series with coefficients, and this kind of thing, and that are 0, 1, and infinity again. And then, Lefschetz here about his singular points of these curves and that, 0, 1, and infinity again. These are the kinds of things that get into a little bit more what's going on about, then finding for these singular regions and what would be 0, what would be the trivial solution for a lot of these differential equations, wherever f(x,y) equals 0 or what. Then figuring out for this identity dimension what's going on that, whether it's either defined on that or it's defined in substitution of variables in that. To get that going as just establishing this above and below even, or just like for Poincare, and his idea of his formula or his theorem that has then this complement about Jacobi or what that is these kind of thing about the path integrals and the curves, that this entire school of the algebraic geometry will much advise what's going on, that as of after the school of the differential analysis, much of which is this analysis Situs or what, and for that we'll look to Poincare some more later, is all to come together as the geometer's playground, and that it includes the grounds otherwise of the algebraic museum and vice versa, to keep those things together while at the same time that it's fundamental in geometry. according to numbers, that is fundamental in mathematics objects, and there are fundamental objects in mathematics. So, with that said, I will hope that my attempts to translate a language in which I'm very poor or not insincere or improper, that then when we want to read something about the models of Voltaire, who was like one of the first guys to win the Nobel Prize or something like that, that we get into these planches, that jargon des parties plans à celles qui leur correspondent. T1 et T1 prime donneront lieu ensuite à une sphère de centre d'un P, sphère dont la surface contient 6 cavités, 2 à 2 symétriques relatives à P, de même portée et to prime. Then it gets into topology, oftentimes what we call the introduction to topology, these kinds of algebraic topology and this kind of thing. But then again, it's really geometries. And that there are different geometries if topology gets boring, but they're the same thing as having various metrics and topologies and transformations among the spaces, that if it's to be written as geometry, it's still kind of one geometry and views or perspectives. Then when you get in a chapter like invariance absolute and invariance relative on geometry algebraic, or absolute invariance and relative invariance in algebraic geometry, then this will be revived. What we would talk about the quasi-invariant measure theory today, because these terms end up becoming too common, relative and absolute, except to use them in their intended essential meaning. Le but du présent travail est de montrer comment certaines de nos recherches récentes peuvent servir à jeter quelques lumières sur les types d'invariance que l'on rencontre en géométrie algébrique. Le groupe fondamental d'une variété algébrique VSVN est, comme on le sait, son groupe birationnel. Parmi ces opérations, il y a lieu de distinguer et les transformations qui ne modifient la dimension de null, v less than VSVN, et introduisent ne font disparaître aucune singularité. Talking about that there's a singularity, so you build two models that is birational. Les transformations à éléments des fondamentaux, c'est-à-dire dont la dimension est altérée, ou qui sont transformés en nouveaux éléments singulaires. It's singular, so it's discontinuous. Anyways, yeah, this gets into a lot of the concepts in the background and where the research was, and that there are multiple schools of the research in the center of the field at any one time, and that geometry deserves a very strong placement in the front of the class of algebra. So these kinds of things we'll get into some other time. Well, have a great day. Or what do the French say? I don't know what they say. Bonne chance.